Just want to do a simple process for extraction of copper. As you know, Zambia is one of the countries which has got a lot of copper, so I just picked these stones from the roadside and I found some aggregates which they are using for construction. So I just went there and picked out some malachite from there, which is basically hydrated copper carbonate. I just want to do a leaching process. So what I'm gonna do is I'll dissolve this, I'll pulp it with water to make a slurry, and then I'm gonna put sulfuric acid in there. So what happens is copper undergoes dissolution in sulfuric acid and forms copper sulfate. And once I make the copper sulfate, I'm gonna show you process where I'll take out the copper sulfate from solution into copper metal powder. As you can see, this is the stuff in a bottle. I just put in water and the malachite, the copper carbonate. I've got with me here a bottle of sulfuric acid, which is 500 milliliters. This is 98.9% sulfuric acid. Very dangerous. So I have to take clear precautions because I'm doing this at home. So try by all means to avoid kids getting into contact with sulfuric acid. So the next step is after putting this in water, I have to start adding sulfuric acid slowly so that I drop the pH and allow the reaction of the malachite with acid to form copper sulfate to take place. It's a topochemical reaction, which means basically it starts from the surface of the solid particles going towards the center as it allows dissolution of the copper from the surface as it penetrates the solids towards the center. So it's going to take a bit of time, but it will be done. It's a very interesting exercise and something you can do at home. Very dangerous. You really need to be very, very careful so that you don't get people injured or rather banged with sulfuric acid. I've actually put the first dose of sulfuric acid into the container, and the procedure is that you add acid into this batch so that when you add it begins to react, and immediately you can see the temperature begins to change, because when you add acid to water, that's an exothermic reaction. So you have to be very, very slowly in the addition of acid so that you don't get to burn this container, because it's a plastic container. So if the temperature exceeds levels it can handle, it will definitely burn off, and then you will lose all your stuff on the floor. So if you've got a glass container, that's the best to use, because it can take that heat, and it has to be glass that can take high temperatures. That will make your process quite faster. But you can see, as I have put the first batch of acid, the solution begins to turn blue. So copper sulfate is blue in color actually. So these levels are quite low in terms of concentration, so it looks quite pale. So as reactions proceed, it will become more and more blue. So let's see how the experiment goes. You can see the bubbles coming out there, the ejection of carbon dioxide from solution as the carbonate breaks. So there's evolution of carbon dioxide from the solution. It also helps in the agitation and exposing more and more copper mineral to the acid so that it reacts. So as you can see, the experiment is proceeding slowly, and you can see the solution is becoming more and more blue. It means we are dissolving more copper into solution to make the copper sulfate. Copper sulfate, when it's very concentrated, it's actually very deep blue, and it begins to crystallize, to form crystals of copper sulfate when it reaches a saturation point. So looking at the quantities I was working with, I don't think we're gonna get to those levels, but we'll definitely make copper. What I want to see you guys to see is the reaction when it's happening on the surface. I don't know if the camera is quite clear, but you can see the reaction happening and the bubbles pushing forward as the hydrated copper carbonate begins to break down. You can see the release of carbon dioxide and the copper going into solution from the oxide to sulfate. So slowly we're getting there.